Another problem I was asked about related to some of the quizzes is similar to this problem. F of x is x cubed times 2 plus 3x all raised to the fifth, and we want to find f prime. Well, first we recognize that we got a product here. Okay, we have a product here, and so we're going to need to use the product rule. But as a part of that product, we also have this function right here, 2 plus 3x to the fifth. And that's a composite function. So as we work that out, we're going to need the derivative of that thing. You can wait and do it as you're doing the product rule, or if you want, as I'm going to do here, I'm going to go ahead and just focus on that problem, work out its derivative, and then later on we can take that answer and plug it back into the problem. So we start here by letting u be equal to the inner function, and then f, of course, would be that thing to the fifth power. So using the chain rule, it would be the derivative of the outer function with respect to its variable times the derivative of the inner function with respect to its variable. Okay, we work that out. Derivative of u to the fifth would be 5u to the fourth. Derivative of 2 plus 3x with respect to x would just be 3. So we get 3 times 5 is 15. And then it's u to the fourth, but u is 2 plus 3x. That's all raised to the fourth. Okay, so that's the derivative of that expression there, 2 plus 3x to the fifth. Now, to take our problem back to the whole problem now, we have a product. So that would be the first, x cubed, times the derivative of the second, that 2 plus 3x to the fifth, that's actually what we've just worked out, plus the second, 2 plus 3x to the fifth, times the derivative of the first, times so it would be times x cubed. So we start to work that out. X cubed times what we've just found out a moment ago, back here in red, 15 times 2 plus 3x to the fourth, plus 2 plus 3x to the fifth, times the derivative of x cubed, which would be times 3x squared. Okay, and now just doing a little bit of housekeeping here. Put the 15 in front, you get 15x cubed times 2 plus 3x to the fourth plus 3x squared times 2 plus 3x to the fifth. Now simplify here, we have to recognize that we have a common factor showing up in both terms. Actually, there's lots of common factors, but the important common factor for us is that common quantity 2 plus 3x. You can also factor out a 3x squared factor. I think I'll go ahead and do that because that's probably what you would see in a lot of answers. Okay, but that quantity needs to be factored out. So here I have a 3x squared that I can take out of both. And then the important thing I have is a 2 plus 3x to the 4th. Take that out of everything. Now when you take that first term there, 15 x cubed divided by 3x squared, I have just 5x. And you take the 2 plus 3x to the 4th divided by 2 plus 3x to the 4th. Alright, they go away, so it's just 5x plus. And then in the second term, 3x squared will cancel with 3x squared. 2 plus 3x to the 5th and 2 plus 3x to the 4th will leave us with 1 2 plus 3x left over. And now we just do the rest of the cleaning. 3x squared times 2 plus 3x to the 4th. And then we simplify what's inside. We can drop the parentheses. 5x plus 3x would be 8x plus 2. And that would be our answer. Now, depending on who you look with, talk to, if you had multiplied the 3x squared through and had, instead of 8x plus 2 there, you just had the 3x squared distributed through and had 24x cubed plus 6x squared, that's fine. Had you taken it one step further and factored out the common factor of a 2 in that quantity, that also would have been fine as well. Okay, so hopefully this question helps you out with the chain rule. Here in this case, the product rule came into play as well.